Yeah, so here we are in sunny Venice. It's the Venice Biennale 2015, and where we have salt-step installed. Yeah, the drawing is the most important place, I suppose, initially where a concept begins, but the other thing that it derives from is a prototype machines and maquettes, but the drawings are the most important area. It's kind of one of those areas where you can completely zone out, like kind of go off into a world where I can really sort of develop things that I wouldn't be able to develop in the studio, you know, like. So salt-step, the work that we're going to try and record the construction and fabrication of and the show has derived from a prototype machine called Hydrostep. This one here, this drawing here, is what I call an earth marking machine, and it has a whole different selection of interchangeable teeth or tools for mark making that allow the machine to walk over various different terrains to propel itself and to also mark make in the area that it walks in. And the marks that it makes I can then analyse almost in a forensic way, and then from those marks learn how to make a machine perform better, so walk better or mark better, scarify in a different format. Here we go. Yeah, so this is what we're making. And so salt-step has 6 telescopic legs that allow it to walk. It's got a very good capacity for walking and balancing, and it's very similar to the predecessor Hydrostep, but it uses, instead of double articulating booms, which Hydrostep was using, it uses telescopic legs. So these bits telescope rather than articulate out. But very similar sort of setup with the joystick control unit and umbilical cord going into the machine, and then there'll be another umbilical coming out for the hydraulic power pack. And then again, the machine comes with 6 sets of step type teeth, and then 4 sets, because it has 4 sets of resting pad or pad type teeth on its belly. But we have modified it very slightly to be amphibious. So this one is like an earth-based one without the hull. But when we show the AutoCAD drawings, we can show like this aluminium hull design that we've added underneath it to make it float, which is quite exciting. The bit that no one sees is actually this bit under here, where the roll goes from an outside roll and slews round into an inside roll, and it's a really like, if you come round actually here, you can kind of see it and kind of see how they pan through, like. So it comes out of a roll and then curves around, and that was a very difficult thing to do, and I'd do it again for sure, but it was very difficult. These here show how a hydraulic system would work on that kind of machine, like the telescoping arm. So the drawings themselves they're not aesthetic sort of add-ons that are sort of done around the sculpture. They're like the old school method of I suppose this is what this table is. It's like an architect's drawing table, but it's like the old school draftsman's method of coming up with ideas. But I suppose I don't have any necessity to draw with a ruler or make them just line drawings. I quite like adding the colour, because colour's very important to me when it comes to finishing the metal. Like, very rarely leave metal bare. If I do, it's sort of like a working component, like a tooth. In the early days of making the drawings, the colour is a very important thing to set out, so that when people are interested in like commissioning something, they know for sure that it's going to be a different colour scheme to my standard honey yellow, which is like the plant machinery yellow colour that I paint a lot of stuff, a lot of the earth marking machines. And then these are, these are like, that drawing's been pretty abused, because it's like basically done at the same time as sitting with Victor. So we're going to go see Victor in a minute with his computer. But so the next step from coming up with a concept is that you would then look at all of the engineering, and the engineering is quite a time-consuming area where me and Victor sit once a week and we sort of just crunch numbers with where plates get welded and how we do things, and I'm sort of making drawings to try and work out how we would get the best out of the structural sort of strength, and how best the hydraulic cylinders will work within the sculpture's legs and arms and so on. This here is a drawing of collaboration with a designer who's designing on Rhino on the computer. Rhino is her AutoCAD program, and I just got these two out because it kind of demonstrates like this different form of drawing, which is like a collaboration between me and my draftsman Victor. Victor's just put together one of the telescoping arms of Six-Step, and we got it together in 3D. We got here the FlowFit hydraulic parts catalogue, and you can see there's a schematic of a hydraulic cylinder. We've got all the measurements of the cylinders here, and so what we can do is we can actually draw a cylinder on the computer and work out its articulation margins within the we can work out the thresholds and what the arm does. Can we make that one move, Victor, like that bit there? So yeah, you can see that bit in there, the yellow bit in there is telescoping in and out. That there is the telescoping ram. This is a drawing made sitting next to Victor. It's like this process of plus and minus, you know, like Victor will draw a number of the same thing, and we'll take one of them or two of them that are good and change them very slightly, and then I know from a perspective of being more of a sculptor than an engineer, that I'm not taking compromise with the aesthetic, that the aesthetic is that of a desired aesthetic between computer, pen drawing, CAD drawing, and then fabrication. We get a lot of steel plate laser cut, because I started using a lot more steel plate in the fabrication now than section steel. But previously I was using a lot of I-beam and section steel and the kind of stuff that you see in like Caro kind of things. But the way that the chassis of earth moving equipment and mobile plant and so on are made in laser cut plate, because you can optimize any form, any strength, and you can make your own section to whatever size, scale you would need it for a chassis or for an arm or for a moving component that's under a lot of stress. So, and it's interesting because like there's something about working with steel plate which is kind of like, it feels more like you're making your ship building, you know. It feels more like you can go off the square. 6 Steps is the first amphibious earth marking machine. So, well, we really wanted to get this feature in it that meant that it would be able to deal with this marsh land or these salt marshes that you get in flow water. And like the lagoon, I'm told, like when the Adriatic has a low tide, these sandbanks come into effect and everyone has a picnic there. The Venetians go out there in their sailboats and rowing dinghies and have picnics on these sandbanks, and this is just like perfect for this machine to operate in. The amphibious attributes and so on make it like more like a creature. So there is something very Venetian about it. The canals often exceeds the footpath, so it often, in high water on the Adriatic, it often can flood ground floors in Venice. So our flood defence system was initially this plinth, but it's also supplied this great new aesthetic for a static work.